Yes, guys. So yeah, I'm audible, all of you. For the last time, can you confirm? Hello, hello. Audible, right? Fine. So basically, in the last class, we have started our discussion with the stresses in an inclined plane, right? Particularly, if you take the inclined plane, what are all the stresses will be acting? That is normal stress and the shear stress. And we have already seen the transformation equations. What are the transformation equations? These are the transformation equations that we got in our last particular class, right? So once again, I will be quickly revising that. Then we will do numerical. Then further we will move on to what next topic, right? So here, if I say you have taken your plane, suppose state of stress condition is like this. You have defined one plane which is being inclined at an angle what theta, and this plane, on this plane, of course, this component might be subjected to sigma x, sigma y, sigma x, right? And of course this will be subjected to, for example, let's suppose like this will be the condition, right? Tau xy which is being acting here, also this will be tau xy. Till this particular part we have discussed, right? All these formulas also we have discussed. Okay, so now try to understand the sign convention that we need to follow while solving this principal stresses part, right? Try to understand the sign conventions that we need to follow for this stresses in an inclined plane, right? For finding the stresses on the inclined plane, first of all, whatever the equation I have given, right? You see these equations. What are all the notations to apply these things? We should follow one standard equations, right? Standard particular sign convention for putting the values of theta and sigma x, sigma y, and tau xy. What are all the sign conventions? That is what we have to see. So all of you, please make a note of it. Just wait, guys. Let me just connect once again. Just wait for 2 minutes. Yes, all of you can see my screen. All of you can see my screen. Can you please check now? All of you. All of you can see my screen, right? Correct. Now, understand whatever the figure I have drawn. Try understanding whatever the figure I have drawn right now. That formula, whatever the formulas I will be putting, suppose sigma x. What is the sign convention for sigma x? If it is acting away from the plane, right? Sigma x will be taken as positive. Sigma x will be taken as positive if it is acting like this, right? So I'm talking about the sign convention that you need to follow, right? Now, this topic is very important, but if you do not understand properly, this will become very, very complicated. Sigma x will be positive. What about sigma y? Tell me, guys. If on a particular plane, if it is acting like that, sigma y will be taken as positive, right? What about tau xy? What about tau xy, guys? Whether it is a positive. Right now, what I'm taking it as positive. If it is acting on this x phase, right? If it is only acting on x phase and making the couple, right? Making the couple like this, anti-clockwise, that will be taken as positive. Getting my point? All of you. Theta. This plane is making an angle with this plane, with this particular plane, with this particular negative x plane. In which direction? Theta in the anti-clockwise directions. Theta in the anti-clockwise directions. So this will be taken as positive. Anti-clockwise angle will always be taken as positive. For our formula, whatever the formula we are discussing, for this particular formulas, theta will be always be taken as anti-clockwise to be what? Positive. Getting my point, all of you? Tell me, guys, understanding? Now, some of you might be having confusion. I will clear that confusion. No need to worry. So if I take this element, this one, A, B, C. If I take A, B, C, so what I'm writing my different on ABC plane, this will be sigma and theta. This will be sigma s. What I can call sigma and theta. I can call this to be what? Sigma and theta, my different, right? And what about tau s theta? Tau s theta will be what? For example, here it is x, right? X, and here it is what? Y. Now, what will happen? Tell me, guys. This will be supposed to be x. This will be supposed to be y. When I rotate this plane by the theta, that is in the anti-clockwise direction, I am transforming my equation from what? X, Y coordinate to what? S and ST coordinates. Getting my point? So this will be what? This will be ST. This will be ST. This will be S. And this will be what? ST. This will be S coordinates and this will be ST coordinates, right? So sigma S, whatever it is acting along this S coordinate, that will be positive. Now, whatever the tau s theta will be there, or we are calling this to be what? Tau s theta. Whatever the shear stress we are finding on a plane which is being inclined at an angle theta in the anti-clockwise direction, that I'm calling what? Tau s theta or sigma st. You can call that to be sigma st, right? Now, if sigma st will be acting along this plane like this, this I'm calling this to be what? Sigma st. Sigma st is in the direction of st or it is in the opposite direction of st. Tell me, guys. Sigma st is in the direction of st or opposite to the direction of st. Initially your coordinates are what? X and Y. Now you have tilted this particular element in the anti-clockwise direction like this. So what about X will also be tilted? That will become what? X dash. And Y will also be tilted. That will be what? Y dash. So we are transforming from X and Y coordinate to X dash and Y dash coordinates. That is what these equations are called as what? Transformation equations. But I'm telling you the sign conventions, right? If particularly on this plane, my dear friend, on this plane, if your sigma s is acting like this, that will be what? Positive. And whatever the tau s theta or sigma st is there, if it is acting in the same direction of y dash, which is being tilted, y become what? Y dash. If that will be there in this direction, that will be positive. All of you getting my point? If that is on this plane, sigma st like this, then what about the other tilted plane? Automatically that will be self-adjusted. This will be like this. That will be what? Making this body to be what? Rotate in the anti-clockwise. And we know that we are dealing with the equilibrium of the bodies. That means what? Other couple will be acting in the anti-clockwise directions with the same magnitude but opposite directions onto the other faces. Is that clear, all of you? If that is sigma st, we will be getting some other values of what? This will be sigma s. This will be what? Sigma y dash. Let me call this to be y dash. Sigma y dash. All of you are getting my point till this point? Tell me guys. Regarding sign conventions, any difficulties? Why I'm forcing onto the sign convention? Because it is very, very important. When we solve the numerical, you will come to know this. Because we have not discussed any derivations, so some of you might be feeling, sir, why only this particular diagram you are taking like this? Why not if the diagram is something like this, that will be like this, then sigma x will be negative and this tau s will be what? Negative. Because we have derived our equations, in our full class, you will see that we will derive our equation by taking this state of stress conditions on a body. Whatever the stresses will be acting, we will be taking that one while deriving these equations, these two equations. That's why we are taking that to be as positive values. Getting my point? If anything will be reversed, the directions or sign will also be reversed. While putting into the formulas, that will also be reversed, right? I will tell the one example also. No need to worry about that, right? So first we will solve the numerical. Based on that, we will see how we can proceed, right? Now sigma x and sigma y will be given to you in the particular problem, right? Now what about the angle of obliquity? Whatever the resultant stress will be there, the resultant stress of what we are calling, what is the resultant stress of sigma s and sigma st, that resultant stress will make some angle phi, right? That will be called as angle of obliquity, right? With the what? Sigma s. And that is what is the value? The value will be what? Tan phi will be sigma st divided by what? Sigma s. And from there you can calculate phi, that will be what? Tan inverse of sigma st divided by sigma s, right? We will solve the numerical. On the basis of that, you will come to know very soon, right? All this fundamental of sign conventions. Now we will solve one numerical, then we will see whether you are understanding or not. Getting my point? Now try to see this numerical. All of you can see this numerical? Yes. Now, which of the following objects with the inclined faces, that is at a 45-degree, right? One plane is there, which is being inclined at an angle what? Theta, that is 45-degree with the this plane, right? Subjected to given stresses. Which of the following is state of stress? That is a MCQ. They are asking which of the following options representing the static equilibrium, right? And I told you this particular formulas in our last class. I told you these formulas we are getting, my different. These formulas, whatever the formulas we are discussing, these formulas we are getting from the force equilibrium. The body we are considering as under the what? Equilibrium conditions. Summation of forces in the y direction, summation of forces in the x direction, we are taking to be what? Equal to be 0. Right? Now, while considering the equilibrium conditions, we got that equation. That means whoever options will satisfy these equations, these two equations, that will be our answer. Right? Now, that will be again time consuming, satisfying each and everything, putting into the formulas. So directly we will be calculating what? Directly we will be calculating sigma s. We are calling that to be sigma and theta. For a given state of stress conditions, we will try to put into the formulas. What is the formula we have? Sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta plus tau xy sin 2 theta. Getting my point? Now tell me, according to our sign conventions, right? If we just complete this diagram, tell me guys, automatically we know some other parts that will be 30. Here also that will be 40, right? Because if we complete the diagram, that will be the picture. Now tell me what about sigma x, whether positive 30 or negative 30. What should I write? Here it should be positive or negative according to our standard sign conventions. Tell me guys. See, I just want all of you guys to attend this demo class very seriously, so that after the class, itself, you can solve the recent whatever the PYQ questions will be there, that you can solve very easily, right? Now, sigma x will be positive. What about sigma y? According to our standard sign conventions, that is 40 megapascal, right? What about tau xy? Whether any tau xy is acting, anything is there? Nothing is there, right? No value has been given in the problem, so that will be 0 megapascal. What about theta? If this is 45, this will also be 45. This will also be 45. So this plane, this particular plane is making an angle what? Is making an angle theta is equal to what? 45 degree with this plane. Then theta will be what? Plus 45 degree. Put those values into this formula and tell me what is sigma s, or we are calling sigma and theta. Sigma x is what? 30 plus t divided by 2 30 minus 40 divided by 2 cos 90 plus 0. Now tell me the values, whether you are getting plus 35 megapascal or not. All of you are getting 35 megapascal as a value. Plus. Plus means I told you, right? This will be our S coordinate. This will be our ST coordinate, right? I told you when the sigma S will be positive, that will be acting to what? Away from that particular plane. That will be sigma S. All the options are showing the values, but the values is incorrect in the option number A. Values is incorrect in the option number C, but value is correct in D and B. So correct answer will be in between B and D. Let's see. Let's find the tau s theta. What is the tau s theta value? Or we are calling that to be sigma st, tau st, whatever you can call, and tell me the values. Minus of sigma x minus sigma y by 2 sine 2 theta plus tau xy cos 2 theta. Automatically this value will be 0 because tau xy is 0. Now tell me the values of tau s theta. Sigma x, that is 30 minus 40 divided by 2 sine 2 theta, that will be sine 90. Again that will be 1. So what is the value? 5 megapascal, right? So tau s theta we are getting 5 megapascal, right? When we are getting the positive value, that means it should be acting what? Towards the st. Then what should be the directions? This will be the directions. 5 megapascal. Now tell me which option is showing the correct diagram. Correct. B option will be correct. So try to focus your attention towards this demo classes. These are the very treat it like a regular classes only, right? I'm telling you, because once you habituated of this kind of sessions, you will be having strength of material will be starting after 4 to 5 months. In between that, you can practice from the textbook, right? And I told you that for GATE examination, you have to practice a lot, right? Without practice, even a simple problem will look a very giant one. But after practicing a lot, believe me, even a very tough problem you can solve within a fraction of minute. 1 minute or 2 minutes, not more than that you will take in examinations. But you have to clear with the each and every step what I'm telling to you. Now, all of you are done with this. And once again, you have to be a little bit patience, right? Can I move to the next segment? all of you. Some of you, I know that you might be having little bit of doubt, but do not worry at all, right? Once in our full class, we'll be starting from the scratch, that is from the zero level. We will be doing the derivation also, so things will be more clarified. Why these particular things are satisfied, basically telling that these are the what static equilibrium, right? Because summation of forces in the x direction will be zero, summation of forces in the y direction will be zero. From that also you will be getting satisfied, but that will be taking time, right? Each one option you have to see whether summation of forces in the x direction, not summation of stresses in the x and y. Don't do the mistake. Summation of forces has to be equal to the zero. Some of you, what you will do, you will balance 35. This will be 45, sir. That will be 35 cos 45. That will be balanced in 35, 30 or not. You will see like that. No, you have to see the particular what dimensions also. You have to multiply with the dimensions, because what is the force? Stress into area. You can take the perpendicular to the plane of the laptop or whatever your screen is there, that is a 1 unit, and whatever the unit is there, that is you can take it as A, B, and you can take it as what, C, and correspondingly you can resolve it, right? You will be getting that option B will satisfy summation of forces in x direction, summation of forces in the y direction to be equal to 0. You can do these things as a homework, right? Now from that thing only, this thing only, whatever the summation of forces are there, we got these equations. You have to believe that, right? Now note on the next topic, principal stresses. Note on the first 4 lines, that is a very important. The principal planes, first of all we will understand what is the meaning of planes. The principal planes are the planes on which only normal stresses will act with the zero shear stress, right? The normal stress across the principal plane will be called as principal stress. For a simple example, if I give sigma x, this is what uniaxial state of stress. Uniaxial state of stress. Why I'm calling this to be uniaxial? Only in one direction stress is acting, right? That is called uniaxial state of stress, right? In this one, can I call this plane AB, CD? Let me call AB plane. Now, can I call this AB plane as a principal plane? Because there is a no shear stress. So can I call this AB plane to be principal plane? Tell me guys. Can I call this particular AB plane to be principal plane? Yes. With the 100% confidence, we can say that AB plane is a principal plane. No doubt about that, right? Now, how to find that particular value? So we have the formulas. That is sigma 1 and 2. Note on the formula. Sigma x plus sigma y by 2 plus or minus half of under root of sigma x minus sigma y whole square plus 4 tau xy square. Right? These are the standard formula for finding. This is a one way. Remember, this is the first way of calculating the principal stresses, where whatever the notations are there, that is sigma 1, that will be corresponding to major principal stress. We call that to be maximum principal stress. Second, whatever the sigma 2 value will be there, that will be called as minor principal stress or minimum principal stress. Minimum principal stress, right? Now, definitely after solving sigma 1 and 2, you will be getting the two values, because there is a plus, there is a minus, right? Two signs are there. So you will be getting sigma 1. What is the formula? Sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 whole square plus tau xy whole square. If you just put the minus sign, you will be getting what? Sigma 2. You will be getting what? Sigma 2, right? Now, here, this is a very important note point. Make a note of it. The plus sign, you will be getting two values, right? Out of the two values, whatever the plus sign will be there, this plus sign will give the algebraically larger principal stress, and the minus sign will gives you algebraically smaller principal stress. Getting my point, all of you? What is the meaning of algebraically? We have to see mathematics wise. Mathematically, we have to see. See, some of you might be, you know that mathematics scale rule, right? Suppose this is a 5, this is a -4. For example, this is a 0. Now tell me -4 is, or we call -6. Now tell me mathematically -6 is bigger or 5 is bigger? Mathematically, or we call algebraically, 5 is a bigger value, right? But with respect to design intuition, remember my see, try to listen my words very carefully. With respect to mathematics, you got to know that 5 is bigger value than -6, right? From the mathematics point of view. For example, I'm just telling you from the design point of view. That means if you want to design certain beam which are being subjected to complex loading case, bending load, shear load, or maybe non-axial load also. All the loads are combined together on acting on a particular beam. For example, and I told you design that beam corresponding to maximum value. Then what you will take? You will take the mod value of -6 or 5. On what basis you will design the beam? I'm talking about the design stress. I'm not talking about the principal stress. Principal stresses are defined based on the mathematically. Whatever the plus sign will be there, the larger the plus sign, that will be the larger principal stress. And whatever the minus sign value will be there, the least minus sign value will be algebraically smaller principal stress. Tell me guys, whether you understood my question, what I'm saying? With respect to design point of view, you got the value -6 and 5. Two values you got it. And if I tell you design the beam for a particular corresponding stresses, maximum stress. So on the basis of which maximum stress you will design the beam? With respect to mod 6 -6 or which one value? That means you got two values, 6 and 5. Whichever is the maximum, 6. So on the basis of design point of view, right, what is the maximum stress? Maximum normal stress on the basis of which you will design the beam is a 6 megapascal. But if the question is asking the larger principal stress directly, that will be mathematics wide we have to see. Mathematics says that 5 is bigger than -6, so 5 will be major principal stress. 5 will be major principal stress and -6 will be minor principal stress. Getting my point, all of you? Tell me guys, suppose after solving sigma 1 and 2, you got two values, 10 and 2. You got two values. Then what is sigma 1? 10. What is sigma 2? 2. No problem, because mathematics also say that 10 is what? Bigger value than 2. Understanding or not? Tell me guys. Yes. All of you understanding? Any doubt? You have the doubt, or is it clear? Now, how to find the particular values, how to find the particular principal plane locations in a particular complex state of stress. For example, this is the second way. I will tell you about this. Now, for example, now once again we will do the example for that. From that only you will be getting the clarity about the all the things which we are dealing right now. Suppose, for example, your material is subjected to sigma x, sigma y, sigma x, and suppose this is the particular value you are getting about tau xy. Now these are the complex state of stress conditions, right? And after solving this complex state of stress conditions, you got to know the you have to find the where exactly my principal plane. Then how to find that? I told you principal planes are those planes where shear stresses will be zero. Then what is the shear stress? What is the shear stress value? Everyone know that sigma x minus sigma y by 2 sine 2 theta plus tau xy cos 2 theta. That has to be equated to 0 because we need to find the theta value where exactly this tau theta is 0. And that plane will become what? My principal plane. Because right now, this AB, CD, no, all the AB, BC, CD, and DA, all the four planes are not a principal plane. We have to find the planes which are being inclined at an angle theta 1. That will be the principal plane. Where tau theta will be 0 and whatever the sigma will be there, that is a maximum value. Right? So that tau theta will be what? 0. Then put the value 0. What we can get? Sigma x minus sigma y by 2 sine 2 theta. That will be tau xy cos 2 theta. From there, my dear friend, what is the tan 2 theta? 2 tau xy divided by sigma x minus sigma y. From there, you can get two values, theta 1 and theta 2. And both the planes will be perpendicular to each other's. Because here one plane will be there, other plane will be getting at an angle what? Theta 2. Right? See here. These are the formulas that we got. Right? And what is the angle between the two planes? Theta 2 minus theta 1, that will be 90 degree. Getting my point? Because if we solve tan theta, you will be getting what? Two values, right? Let me write separately. All of you, please make a note of it. These formulas and these formulas. Theta 1 will be major principal plane. Theta 2 will be minor principal plane. Right? Is it done? Now. So here what I'm saying, suppose tan theta you got 0.8. Now you only tell me what is theta 1 and what is theta 2. Tan inverse of 0.8. What is the value you are going to get? One value will be 19.33 degree. What are the other values, my dear friend? What are the other values? What are the other values? All of you, please check it out. What is the other value? 90 plus 19.33. What is the value? 19 plus, that is 109.33 degree, right? Because if you put theta 2 once again into this equation, you will be getting what? 0.8. Because tan is positive two times. One in the first coordinate, second will be what? In third coordinates, right? So little bit of mathematics will also be required from your end to understand these topics. Getting my point, all of you? Tell me, guys. That's why we got the two values, right? Two planes, and that will be perpendicular to each other's, right? And of course, one more thing. If you are getting positive value, that means what? Both are anti-clockwise. If you are getting the positive values, that will be what? Positive, both will be anti-clockwise directions. Now, here I'm repeating once again, whatever the tan 2 theta is there, whether this formula is clear from where we are getting the formulas? Tell me, guys. It's not clear. Sin theta by cos theta will be what? Tan theta, right? Tan 2 theta. Whether you know this thing or not. Then sin 2 theta by cos 2 theta, that will be 2 tau xy divided by sigma x minus sigma y. That is what I have written. Check it out. If you solve this one, whether you will be getting the two values of theta or one values of theta, tell me. You will be getting, suppose, tan theta as 0.8. For example, tan theta plus 180. 180 plus tan theta, what is the value? What is the tan 180 plus theta? Can I call that to be tan theta? Tell me, guys. 180 plus tan theta will be what? tan theta. Let's suppose, for example, 2 theta, right? So what I can write? What I can write, my dear friend? That will be 180 plus 2 theta. That will be what? Tan 2 theta. So you can consider this to be theta 2 and this to be what? Suppose theta 1. For example, theta 1 is what? 2 theta. Then what is the theta 2? Then what about theta 2? 2 theta plus 180 degree. Getting my point? So here theta 1, we can consider this to be 2 theta, right? So what we can write? What we can write, my dear friend? Just wait. Here you got suppose tan 2 theta, one particular values, right? For example, 0.8, right? You got the particular values. Now tan 180 plus 2 theta will be what? Tan theta. Can we write that mathematically? Tell me, guys. Tan 180 plus 30, if you do that, what you will be getting? For example, tan 2 theta, you got particular values as 1. Now tell me value. For example, tan inverse of 1. If you do that, tan inverse of 1, you will be getting the two values. One value will be what? 2 theta 1, that will be 45. Other values you will also be getting, right? Tell me, guys, whether you will be getting the values or not. One more value. Tan 180 plus 45, you do that, 225. What is the tan 225? Tan 45, you are getting 1. What about other values? 225. That is also 1, right? So 45 degree, that will be 2 theta, right? What about 225? That can be written as what? 180 plus 2 theta. That is what? 180 plus 45. And that I am considering as some other plane, some other planes, that is what? Theta 2 plane. Is that clear now? Why we are getting the two values? All of you. Getting my point? So indirectly, 2 theta is a 45 degree. Then what about the theta? Theta 1. Theta 1 will be 45 by 2. What about theta 2? What about theta 2? What about theta 2? What about theta 2? Tell me, guys. Theta 1 plus 90. Then what is the value? 22.5 plus 90. Then what is the value? Tell me. 22.5 plus 90. That is 112.5. 112.5. That will be the other values, right? 112.5. That will be the other values. Because if you once again you put that values, once again if you just put that value, you will be getting what? Tan 180 plus 2 theta, or whatever the tan 2 theta, if you just put this value, you will be getting what? Once again? Yes or no? All of you. Whether it is clear or no, mathematics. Yes. All of you getting clarity about this or not? Now, if you just move on to the next topic, now make a note of it. How to find the principal planes? I told you, right? Whatever the tau s theta value will be there, the tau s theta value we have to equate to 0, right? So if we just equate to 0, we'll be getting the values. This one, right? This particular formula is clear, all of you? Whether this is clear? For finding the principal planes. Yes or no, guys? Whether it is clear? Now, What about the maximum shear stress and the planes of a maximum shear stress? Now, if you want to find maximum shear stress plane, for a maximum shear stress planes, what we can do, my dear friend? You know the formula for tau is theta, right? Everyone know the formula for tau is theta. Whatever the formula we know, and that is a function of theta. That is also we know. Now, if you want to find a particular plane, suppose any value, if someone will ask you find the plane, then what you will say? You will find the location. How you will find the location? By finding the values of theta, right? How you will find the values of theta? Tell me, guys, mathematically, if I ask you what is the maximum shear stress value, or let's say this is the y value and it is a function of some theta, and if I want to find maximum value of y from the mathematics, what you will do? Dy by d theta, you equate to what? 0. From there, you will be getting what? Y as one particular theta value, right? You will be getting one theta value. You put theta value once again into that to get the values of what? Y maximum. Yes or no? You will do that particular thing in the mathematics, whether you will do or not. Tell me, guys. Yes. See, I'm assuming that your mathematics, basically you have not covered so much of mathematics. So from basic, basically telling you so that you can understand that here what they have done, d tau by d theta directly they have equated to a 0. But from mathematics, why we do that? To get the maximum value of what? Some particular dependent variable. Here dependent variable is what? Tau. On which it is dependent? Theta. That is the independent variables, right? So here you will be getting tan 2 theta once again in this one, right? What is the formula? Tan 2 theta, that will be sigma yy minus sigma xx divided by 2 tau xy. From there, tell me once again, you will be getting the two values or not? One will be theta 3, one will be theta 4. Again, they will be perpendicular to each other. Once again, they will be perpendicular to each other. These are the maximum shear stress planes. Rather call maximum, that will be maximum in plane. Maximum in plane shear stress location. Right? All of you are getting my point or not? Why you will be getting the two values? Tell me, guys. Whether this thing is clear? Correct. Now, here, if you just assume that tan 2 theta 3, suppose you got one particular value, then you know that whatever the theta 4 is there, if you just put the values of theta 4, what you will be getting, my different? Once again, you will be getting the values or not? 90 plus theta 3, if you just put the values, whether you're getting the same formula or not. Tell me, guys. Whether you are going to get the same values or not. Getting my point or not? Whatever the 90 plus theta 3 is there, that is a theta 4, right? For a theta 4 and theta 3 values, you will be getting the same answer, right? If you put that particular value in tan theta, right? Tan 2 theta 3 is there, tan 2 theta 4. Both are having the same values. Both are having the same values, right? How that is the same value? I told you, right? Tan 2 theta 4 is what? 90 plus theta 3. That will be what? Tan 180 plus 2 theta 3. And tan 180 plus theta, that is what? Tan theta. That is the same thing. Getting my point? So from there, you will be getting the two values, right? Tan 2 theta, if you solve it, you will be getting the two values, right? Example I told you, right? Tan 2 theta 1. So from here, you will be getting what? One value will be 22.5 degree. Other value will be 112.5 degree. Both are positive means what? Both will be inclined at an both the planes will be inclined at an angle what? Theta, that is 22.5 degree from a plane in an anti-clockwise directions. Other plane will be inclined at an angle what? 112.5 degree in an anti-clockwise directions from the reference plane. Right? Let's understand what is the meaning of positive values. Right? Now, for example, so all of you have noted down this one so that we can start our discussion. All of you have noted down this thing. Or particularly if you solve by the one example, that will be a very good thing. Now, for example, I'm just taking here 10 megapascal. Here that is 5 megapascal. Now tell me what is the principal planes and principal stresses. Find maximum shear stress, maximum in plane, shear stress location, and its value. If you solve it, what you will be getting, my different. If you just solve it, what you will be getting. And tell me the principal planes. And also find location of principal plane. Tell me guys, how you will find the location of a principal plane? How you will find the location of a maximum in plane shear stress? For finding the location of principal plane, for location of principal plane, PP means principal plane. How you will find the principal of how you will find the location of a principal plane? Tan 2 theta, that will be sigma x minus sigma y, or what is the formula we have? Tell me guys, what is the formula we have? Yes, if you just go back to the formulas, what is the formula we have? 2 tau xy divided by sigma x minus sigma y, right? If you just put into these formulas, 2 tau xy divided by sigma x minus sigma y. Now put those values, tau xy, whether any tau xy is there. Can you see any tau xy? That is 0. Sigma x is what? 10 minus 5. Once again, that value will be 0. Now tell me for which values theta we are getting 0 degree. One, can I say one particular value will be what? 0 degree. One value will be what? Can I say 90 degree? Because theta 2 we know that theta 1 plus 90 degree. Tell me guys. Because tan 180 degree, that is also 0. Tan 0, that is also 0. Check it out. Whether you are understanding or not, guys, this is the pure mathematics, not a strength of material. Yes or no? Whether two values, whether it is clear or not, all of you. Now, how to locate that one? How to locate that? Now, let's locate the principal plane. One value you got the very clear that, and I told you, my dear friend, that is a positive, right? 0 degree and 90 degree, both are positive. Just go back to the first slide. What I told you, a plane which is being inclined at an angle theta from this plane at an angle theta anti-clockwise, that theta will be taken as positive. One is what? 0 degree. That means this plane will become itself one principal plane, and that will be major principal plane. Why major principal plane? Because maximum value or the major value 10 is what? Greater than 5 mathematically. That will be the major principal stress, and that will become what? Major principal plane. Let me denote it by A, B, C, D. So AB will become what? Major principal plane. Right? What is the other value I told you? Plus 90 degree. I told you from the reference plane, this will be my reference plane. For example, rotate the plane at an angle theta anti-clockwise 90 degree. That will be the other plane. AD will be minor principal plane. And what is the sigma 1? 10 megapascal. What is sigma 2? 5 megapascal. Two values we got to know. Whether it is clear, this thing? These things we are doing analytically. But if you just go to the graphical method, that is the Mohr circle, things will become very, very simplified. But before that, you must understand the analytical methods, right? All of you are getting my point or not? Whether these things are clear? Same notation, same sign convention we are following from the very first slide. Yes or no? Now you got to know the meaning of theta, that is positive 0, positive 90 degree. Tell me guys. Yes or no? Correct. Now, what about the maximum shear stress location? Maximum in plane shear location. Maximum in plane shear location. What is the maximum in plane shear location, my dear friend? That is what, to find the maximum in plane shear location, we have to put into these formulas, right? And what are the formula we have? Tan 2 theta sigma y minus sigma xx divided by 2 tau xy. Take it out. This is what the formula we have. Put into those formulas. 5 minus 10 divided by 2. Any tau xy is there. Check it out. Any tau xy is there. 0, right? That will be infinite. If that will be infinite, you only tell me for how many values tan 2 theta will give me infinite values. That infinite particular value. Tell me guys. What will be one theta 3 and theta 4 value? Can you please tell me? What about the theta? Suppose 1090. What is the 1090? 1090, everyone know that. That will be infinite. So theta 3 will be what? 45 degree. And theta 4, we know that theta 3 plus 90 degree, that will be what? 135 degree. 135 degree, my different. Yes, pi by 4. One will be 3 pi by 4. Two values we will be getting the maximum in plane shear locations, right? Because if we put 45 degree, you will be getting infinite. If you put 135 degree into 2, that is tan 270. And when you just put into the calculator, you'll be getting what? Infinite once again. And I told you the proof also, right? Why you will be getting the two values? Because tan is positive in two coordinates. One will be first coordinate, second will be third coordinate, right? Now, so you got to know one value, that is 45 degree. In the same picture, same state of stress condition, this is my state of stress, right? In this state of stress, my dear friend, you just locate the maximum in plane maximum in plane shear locations. What will be the planes of maximum shear stress? How to denote it? That one will be positive 45 degree, one will be positive 135 degree. So one will be positive 45 degree in the anti-clockwise directions. Other value is what? Tell me guys, what is the other value? Other plane will be, can I say other plane will be something like this? Because this is making an angle 135 degree anti-clockwise. Getting my point, all of you? You can represent it like this, or you can also represent it like this. Wait a moment. This is a A, B, C, D, right? Now, one plane I told you, this is a plane which is being inclined at an angle what? 45 degree. Other plane which is being inclined at an angle what? From here, that is what? 135 degree. So if we join together, that will be a plane that is a maximum in plane shear locations, right? That is a plane value that is giving me maximum in plane shear stress value, right? These are the maximum in plane shear locations. Getting my point? The same element, if you tilt it by 45 degree, you will be getting the other state of stress condition where the maximum shear stress will be acting. All of you are getting my point? Tell me guys. Is that clear? At least regarding the sign conventions representation of the plane on the state of stress. Now in this maximum in plane shear locations, whether you have the normal stress value, see what is the major principal stress, what is the basically location part I told you, right? Suppose theta 3 you are getting positive, theta 4 also you are getting positive, that means both are anti-clockwise direction from the reference plane, and that is what we have decided, that to be a reference plane, that one value will be theta 3, that is a what, 45 degree, other will also be anti-clockwise directions, that is what, theta 4. Both are positive, that means what, both has to be represented in the anti-clockwise sense, and that will be the representation of the planes, that will be the representation of the what, that will be the representation of the planes. All of you are getting my point? Tell me guys. Yes, tell me guys. Anti-clockwise like this, please understand. If you understand this thing regarding the principal stresses, that thing will be easy. Regarding the this particular portion, that thing will be very easy, right? We can represent in many ways. I'm not saying this is only one way, but this is a very simple way of doing that, right? Now, so this particular state of stress, we got to know that. Now tell me, this plane which have been tilted, this particular plane, I will be getting, some maximum value. I don't know the sign as of now, right? Let me denote it by tau max. This will be like this, tau max. But tell me, onto this state of stress condition where the maximum in plane locations are there, whether normal stress will be there or that will be zero. Tell me guys. On a in plane, whether maximum whether normal stress will be there, that means I'm talking about here, whether normal stress will be present, sigma n star here, that will be sigma n star will be there or not, that is the point of discussion. Yes, anyone know that? See guys, whatever we have found it out, whatever we have found it out, right, we have found it out the theta 3 and theta 4 just differentiating tau with respect to theta, and we have equated to 0. That doesn't mean that whatever the sigma n is there, right, whatever the sigma n is there, what sigma n is there, what is the formula, we know that, this is the formula we know, sigma x minus sigma y by 2 cos 2 theta plus tau xy sin 2 theta. This is what the formula we know for sigma n. We have not finded out the value theta 3 and theta 4 by equating sigma n to be 0. By equating sigma n to be 0, we have not done that, right? So if you put theta 3 and theta 4 value, you will be getting exactly the same answer for sigma n, and that is not equal to 0. That is not equal to 0. So note down sigma n star value as sigma x plus sigma y by 2. Make a note of it. The normal stress on maximum in plane shear stress. All of you are getting my point? Yes. Because what is the value you got? Theta 3. Tell me guys, what is the theta 3? You got 45 degree. And what is the theta 4 you got? 135 degree. You put that values. You just put that values. Sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta. That cos will be what? 90 degree. Already tau xy was 0 in our case. So that will become what? Cos 90 is once again 0. So that part will be 0. So sigma n star is what? sigma x plus sigma y by 2. That means this thing and this thing both will be same, right? Either you put theta 3 or you put theta 4. The sigma n star on both the planes, on this maximum series stress plane, on this maximum series stress plane, that will be same. Getting my point? Tell me, guys. With the help of Mohr circle, things will be more clarified. But as of now, whether these things are clear or not, tell me. Because theta 3, now some of you might be asking, sir, you just please derive that. I'm not getting the clarity that why exactly we are getting sigma x. You got the value 45 degree, from their basis you are telling, but analytically by putting into the formulas, why we are getting sigma n star, that has to be 0? No. On a maximum shear stress plane, normal stress need not to be 0, right? If it is 0, that is a pure shear plane. Getting my point? That is a pure shear stress plane. That means sigma n star will be theta 3. What is the theta 3? Everyone know that. What is the theta 3? Theta 3, we know that is what? If you just put the value tan 2 theta, that is 2 tau xy, 2 tau xy divided by sigma y minus sigma x. I'm just telling you, you can do as a homework. Now, tan 2 theta is there, right? So you can just take, this will be 2 theta, this will be 2 tau xy, for example, or you can just have the values as tau xy, and this will be sigma y minus sigma x by 2, right? Then from here, my friend, whatever the cos 2 theta is there, you can just find the values. What is that? Sigma y minus sigma x by 2. And what is this? That will be under root of sigma y minus sigma x by 2 whole square plus tau xy square, right? So you can put that value. Let's suppose this is the r, this is r. Similarly, sine 2 theta. Sine 2 theta will be what? Tau xy divided by r. Put those values. After putting those values, you will be getting sigma n star as sigma x plus sigma y by 2. Little bit of mathematics, 2-3 lines will be there. You will be getting the answers. All of you are getting my point? Tell me, guys. I can directly tell you that whether you are getting sigma n star values that is not equal to 0 and what is the formula. But I'm telling you that so that some of you might not be feeling that why it is not equal to 0. So I'm telling you the mathematical reason behind that, right? We have not equated sigma n that is equal to 0. If you just equate sigma n to be 0, for example, sigma n to be 0, that is sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta plus tau xy sine 2 theta. And if you just equate that thing, from there you will be getting the values of theta, that is theta 5 and theta 6. You will be getting the two values. Those values are saying that location of pure shear plane. Pure shear means there will not be any normal stress. That is theta 5 and theta 6. That is not theta 3 and theta 4. That is not the theta 3 and theta 4. Is that clear, all of you? What is the meaning of pure shear plane? What is the in-plane shear plane? That is the in-plane maximum shear stress value. Tell me, guys. Yes or no? Shall we solve the numerical? One more way you can just find the tau maximum value. Now, some of you might be thinking, sir, what is the tau maximum value? What is the maximum in-plane value, right? What is the maximum in-plane shear stress value? What is that? Now we can determine in two ways. One way will be 1 upon 2 sigma x minus sigma y by 2 whole square plus tau xy whole square, right? Or you can also find in-plane shear stress, in-plane shear stress, that is sigma 1 minus sigma 2 by 2. So there are two ways we can determine the maximum shear stress value, right? Now, please make a note of it. This particular value will also be called as a radius of Mohr circle. When we will discuss the start our discussion on the Mohr circle, you will come to know that this is maximum shear stress value. We are calling that to be a radius of Mohr circle. That is a, again, once again, that is a very simple how to find, sir. Once again, what you have to do, whatever the tau s theta is there, what is the formula for tau s theta? We know that minus sigma y minus sigma x minus sigma y by 2 sine 2 theta plus tau xy cos 2 theta. In that theta, what you have to put? What you have to put, my dear friend? Either you can put theta 3 or you can put theta 4, right? Put theta 3 value once again by taking what? Same, that is tan 2 theta, that will be tau xy, that will be sigma y minus sigma x by 2, right? Once again, you find the values of sine theta, you find the values of cos theta from that triangle, put that value, simplify that, you will be getting this one. All of you are understanding or not? Tell me, guys. Now, some of you might be increasing your expectation that to do all these things in a demo class, but believe me, all these things are not possible to derive that. I can directly tell you what is the principal stress, what is the location of the principal planes, what is the basically maximum shear stress value, what is the location of the maximum shear stress plane. Directly, I can tell the value, but I'm telling you the procedure also so that while referring to any book, you can get to know that okay, this is what we have derived this. You can solve the problem by knowing the formulas also. I'm not denying from the fact, but once again, you can just have the derivation as a homework. You can conclude these particular formulas, right? No, 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 both are not same. It is same when there is no shear stress on a particular plane and sigma x is greater than sigma y. Then you can say sigma x and sigma 1 will be same, right? Can we solve the numerical? Right. So what are all the things you have learned till now? You have learned the four things, right? Principal stresses, principal plane, maximum shear stress, that is the in plane, and its location. Yes or no, guys? These are the four things we have calculated or not, right? We know the formula for the principal stresses. We know the formula how to find the principal planes. We know the formula for the maximum shear stress value, and what is the values of what is the location of the in plane shear stress, right? We'll discuss about the theta 5 and theta 6. Now, all of you done with this? All of you have noted down? Now, this particular problem, my dear friend, they have asked this year only, GATE 2023. But I want to solve this problem after discussing the Mohr circle, right? That will be very easy for us to discuss that, right? Some of the things we can discuss as of now, right? Let's see analytical method whether we can solve this particular problem or not, right? This particular problem they have given in MSQ, right? This year only in aerospace. Which of the following statement is or are true about the state of stress in the plane? Once again, I'm telling you, if you have not understood analytical method, no need to worry. You have alternate way or alternate solution called Mohr circle. With the help of that, even a very typical problem we can solve very easily. Read the first statement, what they are saying. The maximum or major principal stress is algebraically the largest direct stress at a point. Algebraically means mathematically they are saying that is the correct statement. Yes or no, guys? That is the largest direct stress or not at a particular point. Minus 50, 0. Let's suppose we have another value to be 100. Then what is the major principal stress? Algebraically, whichever is the largest value, that will be the major principal stress. Yes or no? Understanding or not, guys? Yes. Whether all of you are understanding? Tell me guys. Correct. Now, read the second statement. For a second statement, if I just give one example, sigma 1 and 2, I got two values. For example, I got two values. One will be minus 60, other will be 30 megapascal. So according to definition of the principal stresses, the way the principal stresses has been defined. Now some of you might be thinking, sir, who has defined? Who has defined the principal stresses? Whatever the structural analysis there, way back years ago, they have basically defined the principal stresses by taking all the references, So what is the sigma 1? Mathematically, whichever is the largest, tell me guys, 30 or minus 60? On a scale, 30 or minus 60, whichever is the larger value, 30, right? So that will be sigma 1. What is sigma 2? Automatically, that will be whatever the algebraically least, whatever the larger minus value, right? What we have defined. What is the definition of the minor principal stress? Read that once again. Minus sign gives the algebraically smaller principal stress, right? So out of the 30 and minus 60, whichever is the smallest value algebraically, mathematically, whichever is the smallest value? Tell me guys. Out of the 30 or minus 60, whichever is the largest value algebraically, 30. And whichever is the smallest value algebraically, that is the most negative value, minus 60, that will be sigma 2, right? This will be major principal stress. This will be minor principal stress. What they are saying, this is for example. For example, magnitude of the minor principal stress cannot be greater than magnitude of the major principal stress. Now, if you just take the mod of that, it is greater than what? Mod sigma, that is 30 value. So this statement is what? Incorrect. It can be greater than the magnitude of the major principal stress, right? What is the planes of a maximum shear stress are inclined at an angle 90 degree to the principal axis? Whether what about this statement? Now forget about this statement as of now. Let me talk about the fourth statement. Normal stresses along the planes of maximum shear stresses are equal. Whether it is correct or incorrect. That means they are talking about the planes, location of the maximum shear stresses. That means whatever the normal stresses are acting on a planes of a maximum shear stress, that means this one, sigma n star, whether these things are equal or unequal, they are asking. They're talking about sigma n star, that is equal. This statement is also correct. All of you are getting my point? Now about the third statement, right? They are saying the planes of a maximum shear stress are inclined at an angle 90 degree to the principal axis. Whether this statement is correct, tell me. In this one only, you only tell me yourself, this is a major principal plane, for example, and this is a principal plane. These are the location of a shear stress plane. Shear stress plane. What is the angle between the planes? One is what? 45 degree. What is the angle between the planes? 45 degree. Where it is 90 degree? Any 90 degree you are finding? Tell me guys. 90 degree will be the angle between the principal planes and the angle between the planes of a maximum shear stress plane, but not among the each others. So that is a 45 degree, right? If the statement would have been 45 degree, that is a correct. So here it is incorrect. So which options are correct? A and B. Is that clear, all of you? This statement, this particular thing, except A and B, C and D will be, you can prove it very easily with the help of what? Mohr circle. We will be discussing that. Getting a point or not? Shall we do the last problem regarding analytical method so that you can get the confident, right? Tell me guys. Once again, I'm saying that you just do follow sign convention, which I'm saying to you. Do follow the formulas. You can solve infinite number of problems. There will not be any problem. But some of the students, they want some basically derivations. They want to have the feel for that. So here demo class, I cannot discuss that, right? All the derivations. Definitely in the full class, we will be having full pledge, whatever the derivation will be there. Right? Then only, that is my habit, that before making the development of any topic, just like a physical significance and to have the feeling about that topic, I cannot discuss the problem. Even for a single simple topic also, I will not do that. So no need to worry that directly I will be jumping to the problem directly by telling you the formulas directly. No, that will not be happening in my classes, right? Because who knows that now the total game for the gate examination is depending on what? MSQ. Totally. And who knows that whatever the syllabus and pattern of the examination will be revealed in the month of 3 and 4, coming 3 and 4 months, they will mention that MSQ will also be negative marking. That gone. Till now, MSQ will not be having negative marking. But if it is there, that may be the most satisfying thing who will be understanding fundamentally. Right now, they are guessing like A, B, C, D, anything. If that is correct, they are getting the mark. If not, that there is no negative marking. Right? But I'm telling you, further and further, if gate examination will be happening, keep on happening, total game will depend on what? MSQ only. More two number of question you will be seeing in MSQ rather than numerical answer type or maybe MSQ. MCQ, this one. So if your fundamental is not clear, theoretical, physical significance about each and every topic, even you solve 1,000 problem, you cannot solve the problem which will be given by IIT professors. That is a very, very harsh reality, I'm telling you, right? Now, so let's discuss this last problem regarding the analytical method. Then we can solve the Mohr circle method, right? We can discuss about the Mohr circle. Now, this one for the state of a stress shown in the figure, which of the following represent the correct free body diagram about which showing the maximum shear stress and associated with the normal stresses. Now you can see this particular problem, all of you. Tell me guys. All of you can see the problem. Tell me sigma xx value. Tell me guys. What is, I'm going to show you the particular options also. These are the options, right? These are the options. But for discussing the regarding the options, let me just ask you what are the notations, sign convention we have followed. First of all, we will note down that, then we can proceed that regarding with the options. What is the sigma xx? Positive or negative 18 megapascal? Tell me guys. Acting away from that plane, that means positive, right? What about sigma yy? Plus 12 megapascal, right? Plus 12 megapascal. What about the tau xy? What our sign convention is there, we taught there, like this. If it is like this, it is positive. Which one? Tau xy. So that is positive or negative? Plus 4 megapascal, right? Like this it is acting, right? Getting my point now. So this tau xy will be what? 4 megapascal, that is positive. Now they want to calculate this plane, this particular plane will be tilted at some angle to find the maximum in-plane shear stress and associated normal stress. Let's see about that. So we know this one. What is the location? Tell me guys, what is the location value? How to find the location value? Tan 2 theta. What is the formula? Anybody can tell me the answer for theta 1 and theta 3 and theta 4 very quickly? You know the formulas, right? Tell me guys. What is the tan 2 theta? Yes. What is the value? Sigma y minus sigma x divided by 2 tau xy, right? So here what is sigma y? Sigma y is 12 minus 18 divided by 2, that is 4. From here, what is the tan 2 theta? That is minus 6 divided by 8, so minus 3 divided by 4. For maximum in plane shear stress. Getting my point? Whatever the 4 by 3 you are saying, that is for the major principal, that is for the principal plane locations. We are not interested in the principal plane locations. Read the statement. What is the location of the maximum shear stress and associated normal stress, right? This particular, all the option has been tilted. What is the amount of tilting they have done? That is what we need to find first of all with the help of theta 3 and theta 4. From here, you got tan 2 theta as minus 3 by 4. You will be getting theta 3 and theta 4. Tell me the values. What will be the theta? What will be the theta 3 value? Tell me, guys. What about the theta 3? If you just calculate tan inverse of minus 3 by 4, that is minus 36.86. So if you just do that, minus 36.86 divided by 2, so theta 3 will be minus 18 point what? 43 you will be getting, minus 18.43 degree, right? That is the one value of the maximum shear stress strain. What are the other values, my dear friend? Other values directly you can calculate. What is that value? Theta 3 plus 90 degree. What is that? 90 minus 18.43. You will be getting the values theta 4 as 71.57. Once again, put that value 71.4757 into 2, and tan of that, whether you're getting minus of that or not. Yes, minus 3 by 4, that is minus 0.75. That means you got two values. One is a negative, other is positive. Now tell me, what is the meaning of negative? What is the meaning of negative, my dear friend? The negative means from our reference plane, that plane has been tilted in the clockwise directions, right? That plane has been tilted in the clockwise directions. By looking at the figure itself, any blind person can tell me that this particular plane is there, right? And this plane has been tilted in the clockwise, right? That means one plane will be something like this, right? One plane will be there at an angle 18.43 degree. One plane will be this one. What about the other plane? Or maybe let me write clearly so that you can come to know about the plane, because representation of the planes are very, very important. This will be one plane which is being inclined from the reference plane in a clockwise direction. Other plane is what? 71 point. What is that value? 71.57, right? 71.57. That 71.57 positive means what? Anti-clockwise direction. What about the anti-clockwise directions? Tell me, guys, what is the value? What will be the directions? Clockwise or anti-clockwise? What about the other planes locations? If you just take this plane will be represented by what? In a anti-clockwise 71.57. So this is what my plane is there. This is what my plane is there. That means from a particular given plane of stress condition, this plane has been rotated by this particular angle. Can I say this plane has been rotated by this particular plane? Check it out. By 18.43 degree. Just check it out. So which option is correct as of now? Check it out, guys. The plane, this is wrong option. A will be incorrect. Whatever the option is there, because that they are saying that this has been tilted in the anti-clockwise direction. 18.4 is not anti-clockwise direction, right? What they are saying? They are saying from a plane, this will be the plane they are showing, right? That means they are saying that this particular plane, that is not the anti-clockwise direction. This is incorrect. 18.4, once again, three options are there, B, C, D, right? In the B, C, D options, now we need to calculate the values of normal stress. What is the normal stress formula we know? On a plane of in-plane maximum shear stress, sigma x plus sigma y by 2. What is the sigma x? Sigma x, we know that 18 plus 12 divided by 2, that is what? 30 divided by 2, that is 15 megapascal, right? That is a positive. That means this option will also be gone because it is acting towards that. This is gone because this is correct. Now we got the two options, right? B and D. Any possibility is correct. Now, how that can be decided? That can be decided by calculating the tau s theta on a particular plane AV. For example, If I got to know my different, what is the value of the shared stress directions on a plane AB, other plane direction can be easily identified and we can tick the options, right? Now let's calculate that. Now, if you want to calculate, suppose for example, if you are interested in this particular plane, what I can say, this plane, for example, you are interested in this plane, AC plane, right? Now, on AC plane, I want to find tau s theta. How to find tau s theta value? 71.57. You want to calculate the values, right? What is the formula we know? What is the formula we know, guys? Tau s theta value, right? So sigma x minus sigma y by 2 sine 2 theta plus tau xy cos 2 theta, right? These are the values we know. Now, what is sigma x? We know that. What is the sigma x? 18 minus 12 divided by 2. Now, what is the sine? 2 minus plus of what? 71.57. Tau xy. Any tau xy is there? Yes, we have 4 cos 2 times of 71.57. Now you tell me the values, final values. What is the value you are getting with the sign? Any one of you can please tell me? Minus 3.2. So that is nothing but minus 5 megapascal. If that is minus 5 megapascal on a particular plane, my dear friend, I told you what will be the directions. What will be the directions? Tell me, guys. This particular plane has been tilted in which directions from our reference plane? Tell me, guys. That was my original plane, for example, and now this has been tilted, right? This has been tilted like this. So what is my coordinate system? The coordinate system will be, this will be my what? Or we can take this AC plane or BD plane, both are same plane. What about the directions? Theta, that will also be same, 71.57, right? So what about the axis? What about the axis? Initially axis was x, now you got tilted by x dash, and now it has been tilted by what? Y dash, right? I told you in the options, basically sign conventions, whatever the values of tau s theta we are getting, whatever the values of tau s theta we are getting, if it is getting positive, that means it will be acting along the y directions, y dash directions. But now we are getting negative, that means where it has to be act. Where exactly it has to be acting? It has to be acting opposite of that y dash. That will be minus, that will be 5 megapascal. Other, you should not bother about that. If that is what? That is acting in the downward direction, definitely on AC, it has to be acting like this, right? And that is making clockwise, so other has to be something like this. Now you can just clarify which option will be correct. B will be correct, because this is showing the wrong directions of what? Tau s theta. Whether these things are clear? Tell me, guys. You have to decide the plane, you have to decide the theta, right? That is a very, very important thing. All of you understanding? Yes. Tau s theta, that is what? Now, once again, let me clarify that. Now, some of you might be thinking, sir, you have calculated for theta is equal to that. You have not calculated for a particular angle, this one, right? This for AB, I want to know, sir, how we are getting the angles, right? For that, let me show that calculations. So here you got to know this plane, right? This particular plane, like this, you are getting the planes, right? Check it out. This is how we are getting the planes. Correct. This is A, B, C, D. Right. So we have calculated for BD plane. What about the AB plane? What about theta? Clockwise. What is the value? Minus 18.43. Now you calculate the values for tau is theta. Minus 18.43. That means you just calculate for AB plane. What is the formula? Same formula we have. Sine 2 theta plus tau xy cos 2 theta. Now you just put the value. What is the value? 18 minus 12 divided by 2. Sine of what? 2 minus 18.43 plus tau xy. What is the tau xy? That is 4 cos of what? 2 times of minus 18.43. Now just any one of you can tell me the answer for this. 18 minus 12 divided by 2 into sine of this will be 1.8 plus 3.2. So whether you're getting 5 megapascal, all of you, that is a positive. What is the meaning of positive, my dear friend? All of you. What is the meaning of positive? Initially, my coordinate system was like this. X and Y was something like this. Now, if I rotate my plane, something like this, understand very carefully. This is a very, very important. Now, on a particular plane, this is my what maximum in plane shear planes, right? Now, this is my AB. If I tilt this one, this will be my X dash and this will be my Y dash, for example. Initially, this was Y and this was what? Y dash. This is Y, this is X, this is Y, right? If I tilt in the what? In this anti-clockwise directions, what you're understanding? That X dash and Y dash will be tilted. Similarly, what about this one? This will be what? Tell me guys. This will be X dash. Can you say this will be Y dash? Tell me. For a plane AB. Yes or no? All of you are understanding what I'm saying? Because for this AB plane, for a AB plane, what you can say? For a plane AB, this will be suppose X axis, this will be Y, right? And the axis of the plane, which is being tilted at an angle what? Theta, for example. Then what about the coordinates? That also that will also be tilted, right? So what we can say? So this was the original X that has been tilted by what? X dash and Y dash, right? This Y will also be tilted. That by what? Same with the angle. What is the angle? Whatever the angle is there, which X dash will be tilted with the same angle, Y dash will also be tilted with the Y. Similarly for AB also, X dash and Y dash will be something like this. Now you got 5 megapascal. Now tell me what about the direction of tau is theta? Is it in the same direction? According to our sign convention, if it is positive, that has to be in the same direction of Y dash. So that will be acting like this. Once you got the location of one plane, other will be easily decided, right? So either you do by AB or you do by BD, you will be getting the same answer for shear stress locations and the values. Check it out. But my suggestion will be it is very easy to go with the directly like this, right? Whenever you will find the locations, you just find the planes which are being inclined at angle what? Theta like this, because that will be easy for us to tilt X to X dash and whatever the Y is there with the Y dash, right? Instead of tilting for AB and AC, that will be very, some of you might be confused in that. So it's better that you tilt that one regarding the plane which is being inclined at an angle what? Theta anti-clockwise. That will be easy for us. All of you understanding? Tell me guys, whether it is clear. All of you. Sometime, whatever the axis is there, sometime whatever the axis is there, which is being inclined at an angle theta, let me tell you the shortcut, right? Instead of seeing the where the y dash, where the x dash, sometime, you might be having problem in the tilting also. For example, some of the times you will face the difficulty in tilting, right? So this plane is there. Suppose this has been tilted in the clockwise direction, right? So initially this was x, right? So that will be tilted with the what? In the what? Like this. So sometimes it will be difficult to tilt. So let me tell you the shortcut for the direction of shear stress. Understand? Whenever on any plane, remember what I'm saying. You know the conventional way, right? Whenever you are finding the on a plane inclined at an angle theta, tau is theta, like this. You imagine the other half of the plane which complete the particularly state of stress condition on other plane. On this plane, if it is tau is theta, our answer is positive. Or you can also assume on a plane onto the other one, this might be acting like this. So that will make the constitute what? Couple in the clockwise directions. Getting my point, all of this? Understanding what I'm saying? If that is making clockwise couple, that will be positive. Tau is theta will be positive. Getting my point or not, all of you? Tell me, guys. All of your understanding? Now let me just verify with our problem, right? In our problem, we have determined which particular values on this plane, right? This particular plane, which is being inclined at an angle what? With the vertical plane. With the vertical plane, with the either this vertical plane or this vertical plane. That has to be a vertical plane, right? With the vertical plane at an angle theta, positive, that means anti-clockwise direction, we got to know tau is theta to be negative. Negative means what? Negative means what? You just plot this one. Negative means earlier I told you when it is positive, this has to be in the couple like this. Negative means it has to make anti-clockwise. No need to tilt your hand or whatever the coordinate axis. Directly with the help of that, you can get it. That if it is negative means what? It has to be anti-clockwise. Anti-clockwise means what? On this one it is like this. Which option is showing that one? This one, right? All of you understanding? Tell me, guys. All of you are getting my point? Now you verify for AB also. You verify for AB also. I have given the example for two things, right? You verify for AB also. For AB plane, what is going to be there, right? For AB, that will be my this one. This will be my AB plane. That is what positive. Positive is what? They has to constitute a clockwise with the other half of the plane. That has to be what? Clockwise. Check it out. Whether they are making the clockwise or not, you only verify. Tell me this. For a particular AB plane which is being inclined theta clockwise, whether it is constituting the couple with the other one in a clockwise sense or not, being positive value. Tell me guys. Yes or no? Whether you are getting or not, shortcut. Ultimately, you will solve in the GATE examination by shortcut only, right? What I told you, the tilting and all, that is for conventional way to understand the things. Getting my point? You can also verify for CD also, you can also verify for AC also, right? Whether for AB or CD, both are same thing, right? Sorry, because both are making with the vertical and clockwise, right? Check it out. Whether it is clear, all of you. Whether for AB or CD, both are making what? Clockwise sense, 18.43 with the vertical, right? Vertical plane. Some of you don't be so rigid about, sir, this plane only we have talked about while derivation. Where about this plane, sir? You are taking now this plane with the vertical plane in the anti-clockwise. Need not to be that particular plane. It has to be a vertical plane. Getting a point, all of you. Now, so let's solve
Sir,
the.
sir, will wind up here.
Okay.
If it may take some time, right? So
So this for
I
last
think,
problem we can discuss.
yeah, I think, but it will take some because you explain many things in your question. So I think
Yes.
we will do it later when we do regular class because these guys have another class from 8:50.
Okay.
And
Okay. Okay.
yeah, so guys, if any concern, Rupali, you can write in chat like
You can
how you.
solve this one as a homework if you want.
Yeah, you guys
Please
can
take
solve as a
note of
homework.
it.
Yes, because after engineering mechanics, either we'll be moving to fluid mechanics or solid mechanics. We'll
Okay.
decide. So, so guys, anyway, we will be teaching everything in depth again. So not an issue. Okay. So we'll wind up. Anyone? Yeah, Rupali, anything you want to ask or share? So this is our online teaching platform. Okay, and it's very interactive and very good as well. And I'll share the Rupali our course introduction video also. You can go through and then decide. Yeah. So thank you, sir, for making this
Yes, sir.
session, and thank you all for joining. And you guys keep being off, regular classes well, and solve the assignments related to that. And that's all from my side. And yesterday, anyway, we have discussed how GATE is so important for aerospace students. It is also very important for other stream students also, but for aerospace, it's like only and only best opportunity. So, thank you all. Thank you, sir, for
Yes, sir.
making this session. Thank you, sir.